In electrochemistry, the electrode potential of the cell cannot be found out directly, like they are not the thermodynamic functions, so they cannot be added or subtracted by any means, but the potential can be calculated for the redox reactions by the formula, like by using the value of delta G. Now delta G is a thermodynamic function, so it can be added or subtracted. Now for example, if we have an equation Fe3 plus gains 1 electron to form Fe2 plus, now E0 value is given 0.77 volt. Now Fe2 plus gains 2 electron to form Fe. If we have an we have E0 value, that is minus 0.44 volt. Now we want to calculate the E0 value for Fe3 plus gains 3 electron to form Fe. Now for this, if we want to find out the E0 value, we can find out by using the delta G0 value, but we cannot add E0 values directly. So delta G0 for the first equation is minus NF E0, which is N is the number of electrons which Fe3 plus is gaining, so it is 1 minus 1 into F into E0 value is 0.77 volt, so minus 0.77 Faraday. F is the Faraday constant. Now for the second case, delta G0 is equal to minus NF E0, where N is the number of electron gained by Fe2 plus, that is 2, so 2 into F into minus 0.44, so minus minus becomes plus, so it is plus 2 into F into 0.44, so it is calculated to be 0.88 Faraday. Now we have to find out delta G E0 value for Fe3 plus gains 3 electron to form Fe. Now delta G0 for this equation is equal to delta G1 plus delta G2. Why? Because these two equations can be added to form the third equation. So we can add delta G values. So which can be calculated directly, like minus 0.77 plus 0.88 Faraday, that is equal to 0.11 Faraday. Now E0 value can be calculated like minus 3 into F into E0. Why 3? Because number of electrons gained by Fe3 plus is 3, so which is equal to 0.11 F. So E0 value is equal to 0.11 over 3. Okay, now let us take an example, like for the half cell we have given thallium 3 plus to thallium plus and thallium plus to thallium. E0 values are given like 1.26 and minus 0.336 volt respectively. Now E0 value for the half cell, if we want to calculate the E0 value for thallium 3 plus to thallium, now we cannot add the E0 values or subtract the E0 values, so we have to apply the thermodynamic function, that is delta G. So thallium 3 plus to thallium, like thallium 3 plus is E0 value is given 1.26 volt. Now thallium plus to thallium, E0 value is given minus 0.336 volt. So now we have to find out thallium 3 plus to thallium, means thallium 3 plus is gaining 3 electron to form thallium. Now delta G for the third equation is equal to delta G1 plus delta G2. Now in the first equation it is gaining 2 electrons, as thallium 3 plus gains 2 electron to form thallium plus. The thallium plus is gaining 1 electron to form thallium. These are all electrode potential, reduction potential values. It means now delta G3 is equal to delta G1 plus delta G2. So N3 E0 3 F is equal to N1 E0 1 F plus N2 E0 2 F. Now the number of electron gained by the final equation is 3. So 3 into E0 3. F can be cancelled out from both sides. So 3 into E0 3 is equal to 2 into 1.26, which is given in the first equation, plus 1 into minus 0.336. So E0 value for the final equation can be calculated directly by adding the thermodynamic parameter delta G0.